here we are. So we have already configured the third router, R3. R3 is already configured. Let me change the configuration here to a larger. Run show interfaces. So R3 is already configured according to our drawing, our logical diagram. And first, in the last video, we had to make a static route so that this computer, the CentOS, could achieve the IP address of the HT0 from R2. And if you want to access this interface, we'll have to do the same. And so we are going to see the need why we do have to work with dynamic protocols. So if we want to exit, oops, what's the matter? Exit. If you do a ping to 192.168, 10.00.10, this is the IP address of the R1 HT3. It has .10. Then you can arrive and you have the echo reply. If you want to ping the 9, you can't, and the reason is because you can't, don't have no static route. I'm here on R3, show IP route. You don't have no static route to send back the package. So the package comes here and the router then sends to this interface, but the R3 doesn't know where to send the package directly to this network where it came from. So you have to configure this routes, set protocols static route, and we'll say the address 192.168.10.0/24 will be the next op will be 10.00.10, the IP address of R1. We are still waiting for the echo reply here on CentOS. As we do the commit command, the router accepts the new configuration and it starts pinging again, or sending the echo reply back to CentOS. Now, question: what about if we want to ping this interface or this other interface? So is it possible that this router, the CentOS can ping this interface? Why? Or this interface? Why? Because what? Because this router, when you send the package here to R1, the R1 doesn't know this network. As you can see, the R1 has a default gateway route that sends all the package back to the 1. So let's come here to, I'm going to open here another SSH Vyos at 192.168.10.254, the password, and we are here on R1. If you begin to ping 10.0.0.5, the IP address of R2 HT3, and here on R1 you're going sudo su, you make a TCP dump, listening to what arrives to interface HT2, all the traffic that comes ICMP / like this, nothing arrives to this interface. We are listening to what arrives to this interface and nothing arrives. there is no package sent by the CentOS. So let's listen this interface to see what happened. I'm going to close this, and right now I'm going to listen on HT0. And as you can see, all the package that was the source address of the package is from the IP of the CentOS. So it's sending back to this is where the information should be going, the IP address. But what the router does is sending this information directly to the one. Why? Because right now we're going to see what are the routes that the R1 have. And let's, if you exit, if you show IP route, and here's default route that was given by HT0, because this interface is connected by DHCP. So as this interface gets the IP address directly from the DHCP, it also gets a default route, or last resource gateway route. So all the packages are being sending directly to the one. So what we have to do is, since the package, this router doesn't know this network, so we have to give him a static route saying that if one package arrives here and arrives to this network, it will send from this interface or that interface, it doesn't matter, so that the R1 knows what to do when the package arrives to him. So let's configure this and configure, set protocols. You'll say static route, and the static route will be when you're sending information to this network. Static route, you will give 30. You will send next op will be not valid. Protocol static route, sorry, missing route. Now it's the network. 4/24, you'll send next to 10.0.0.2, for instance. Next router, yeah, 10.0.0.2. What's next op? What's the problem here? Router required. So the router 10.0.0.1. Yeah, sorry about it. Yeah, the net mask was not correct. It didn't know the network. So commit, and right now, if you come here, now we have the pinging. Now it's pinging. If you do a trace route, I hope I have the trace route. We don't have the trace route. So pass ping, pass check, pass ping, pass check, pass ping. We don't have no pass ping. What's the other command? Trace ping, trace pass. Okay, trace pass 10.0.0.5, and right now we're saying that it comes from here. It's going directly to the gateway, and it goes then to, and it arrive. We are missing here a trace route. Would be nicer, but no problem. We'll install it. So now run show run show IP route. Now we have this route and we have the static route. Okay, but now tell me, if the R1 has this route already and now we have another static route, why is he sending this information back to that interface? Doesn't he stay confused having one, and this is the first static route that he receives, or that he checks when the package arrives to him? Why doesn't he send back to HT0? Why? Look, because this is the weight of the static route. This is directly connect. We didn't say the weight, and so since this route, this default last gateway route, has a value of 210, is much bigger than this one. This is directly connect. So he sends, without questioning anyone, he sends directly to this interface, to 10.0.0.2. But look at the drawing, and if you want to get to this interface, what you have to do? We have to do the same thing, right? We have to create a static route on R1 saying that it should send the information to this interface. The same would be will also be applied here to this network, and that network. So you have to fill this router with fill with static routes. To avoid that, so we have the RIP protocol. Right now we're going to configure RIP on these routers. First, let's say how we can delete a configuration on the router. A few moments ago I've done this configuration, and on this configuration, now if I want to delete, what you do in Cisco, you say no, right? Here you say delete or del, and right now we will send only this protocol static route. I'm going to make commit. What? Commit failed. What happened here? Commit. It's either next up or a black hole for route. Static route. What's the problem here? Let me check. Don't understand what's the problem right now. No. Now, protocols, we have loop back low, Ethernet interface. I don't have no route here. Commit. Okay, save. It was and now run show IP. Okay, now we don't have that static route already here. So to configure RIP, first of all, we have to be on configure mode. I'm going to make exit, so I'll do all the configuration from the beginning. Configure. Then we'll say first we have to configure loopback adapter, or at least it will be more easier to understand which is the neighbor of the RIP protocol. So set interface loopback low, and generally we give the 111 the IP address of the router with the mask, the 32 bits max address, and with this we give the IP address of the router with the same 32 bits. Now we're going to begin to do set interfaces, set protocols, and on protocols we'll say that will be RIP and then network, and the network that we're going to say that this router will say to each other will be this network, and this network also. We won't inform the others that he has this network, because that network is the connection for outside. So RIP network 192.168.10.0/24, and then we say the network 10.10.10.4/30 and the network 8/30, and we'll do a commit here, save, and if you do show run show IP route, you'll find out that right now you don't have no RIP configuration, no hurry, and if you say show RIP, show IP RIP, you'll find out that right now is announcing two networks. Okay. Now let's go to R2. This is R3. I'm going to exit again, and here show IP route. He has one static route that we gave him, and we're going to delete that configuration, and so configure, you can do a delete protocols, protocol static, and enter, commit, save, exit, and right now if you do a show IP route, you don't have no static route. So let's start the configuration. Configure, set interfaces, first of all loopback adapter, low address, this is the second router, so it'll be 222/32, and set protocols RIP, and the network that the R2 is connected, it's 1030, this one, and this one here. So network 10.0.0/30, the fourth network, and 192.168.10.0/24 and 30. Also, before you do a commit, when the RIP protocol is implemented, the way the RIP works is he sends all the networks that he knows by the interface. So here on this network and on this network, the hosts that might be here, they don't need to know what network the router has. So in this case, this interface, they must be in passive mode. Okay, so the passive mode means that the router won't send all the networks that he had acquired from the other routers to this network here. So the configuration, the network stays with less transfer and less information sent back to the interface. I had a break. So you have to do is to do a passive interface. Set protocols RIP, and on RIP right now you have the passive interface, and you'll see that will be HT1 and HT2, and then you do the commit, save, and right now if you look at IP route, you'll find out that is right now what happened. Where are the other networks? They should be sending information. Why the R2 doesn't receive the information from... it's missing, yeah, it's missing something. Set protocols. He has to announce all the information that he knows. So he has to say RIP, redistribute connected. Okay. So commit, and then now, and here the same. Oh, not in here, sorry. Conf set protocols RIP redistribute connected. Okay. Commit, save, and now exit. I don't need to do exit. Show, run, show IP route. It's not. Well, why is not sending the? Why is not sending the information? Problem? Run, show IP route. No. Set protocols RIP redistribute connected already exists. Yeah. Commit, save. So what is it? Show IP route. Why is it not sending information? Houston, we have a problem. Why is not sending the networks? It should be passing by the information. Yep. Okay. R1. Houston, we have a problem here. Why is not sending the information back to each other? Well, it should be show IP RIP yep. 3030. It's okay. 8, and here show IP RIP yep. Network 4 10. Bum 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 bum. Well, let's reboot the router. This is R2. Check, and this is R1. This is R2. Let's make a reboot here. Yes. Right now it's rebooting. Let's do the same on R1. I can't check why it doesn't transfer the networks between routers. This is new. Pum 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 pum. Can't understand why. Really? Where is the problem? Pum 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 pum. Login, sorry. Well, boom, 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 boom. Now I'm going to configure the third router with R1. I don't know, it never happened to me. This never happened. It's always a first time. Sorry. There is always the first time. Oh, 10 it's itself, sorry, it's 9. It's 9. R3. Show IP route. Okay. Conf T. Missing address here. RIP network. 20, 40, right? And 50, right? 500, yeah, it's a good network. And then set protocols. RIP, redistribute, connect. Yay! What happened? It's amazing. It's amazing. Just amazing. Okay, let's log in. R1 again. Yay! Bum 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 bum. Well, we can go SSH directly here. Vyos can go directly to R2. Yes. So again. And it's configured. Why it wasn't before? I don't make the slightest idea. Don't make the slightest idea. I don't make the slightest idea why it wasn't working before. So R2, R1. So let's check here. As you can check, I don't know what happened. Really, I don't make the slightest idea. Show IP route. Perhaps if you are watching the video, you could say show IP route. Now, as you can see, we are on R3, and you receive this information regarding the first router who had this local IP address. And here, you know that to get to this network or to get to this one, if you send information from R3, the best way you give 2 jumps, and then you go straight ahead HT0. So let's look at so if you are here, if you want to send information to this network, you have to send for HT0, and you have to give 2 jumps, 1, 2, to arrive to the network. If you want to go to network 30, you have to give 2 jumps, but right now you go from network, you go directly from network 5. I don't know. I'm still don't know what happened, because the information should appear. Show IP route. Okay. On router 2, if you want to go to network 10, then you have to give 3 jumps. Oh, that's amazing. That's good. You have to give 3 jumps. You have to go by H3. Good, 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 good. This is not okay. There is a problem. I don't know. I think that R2 and R1, they had an arguing, and they don't accept information from each other. R2 only sends information via HT3. That is, R2, if he wants to send information here, he'll go past directly for R3. R3 doesn't make any sense. It should go by here, but I don't know what happened. Perhaps they argue, but perhaps they don't like each other. Anyhow, and R1, let's check about R1. Show IP route. Again. Show IP route. And good. I think that we have a problem. Yeah, for sure. All the information that is sent through R1, even from this network or this one here, is sent via HT3. It means that all the package must travel this way. So we had here a problem, which I don't know what it was. They don't communicate right now. I don't know. I don't know what happened. I'm going to put the comments. I'm going to stop the video here. I'm going to check what's the reason why, but I'll send you all the communication comments. Just